Well, thank you for coming, and thank you for the introduction. As you said, my name is Lilly, and I am a product manager for Open Knowledge Foundation, and I work on the Frictionless Data for Reproducible Research project. And my background is in neuroscience, and I feel like I'm in good company because there have already been 2 talks today by neuroscientists, which is kind of a funny coincidence. But I am working in open data and open source research now. And today I'll be telling you about our project, Frictionless Data, and how we are working with the researcher community to help them resolve their data pipeline issues using this open source software. And I want to point out 2 things. I have the link to the slides posted here. It's this bit.ly link. And I put that up there because there's lots of links in the slides that for later after the talk, if you want to get the slides and go in and explore more content, there's lots of links. And I will probably tweet out the link to these slides so you can find it that way as well. And we are hiring a Python developer right now. So there's info at that link at the top, and if you want to learn more, you can come talk to me later about that. So I know we just ate lunch, and I thought that it would be good to start this talk by talking about data in a food question. So here's my question that I want to start with, if the slides will progress. They're not progressing. There we go. Okay, here's my very important question for you. As the water temperature in the Gulf rises, will this lead to less shrimp, which could lead to less shrimp tacos in Austin? And we can argue about what the best taco filling is later. But I put up this question to start thinking about data. And what kind of data can we use to answer this question? We can, ask about the lifespan of shrimp in the Gulf. We can collect data points about the temperature of the water in the Gulf. And say then we could, map it out, plot it, and do an analysis, and then we would know the answer to this question, right? Pretty straightforward, but it's actually not straightforward at all. I'm leaving out all of the parts that you do with the data before you get to the actual analysis steps. Things like data management and collecting the data and understanding the background of the data to really be able to work with the data. Things like what time of day were you collecting those data points about the temperature of the water? Questions about, were those data points collected from the same species of shrimp? And these are the questions that are really important that we sometimes overlook when we're handed data and then do analysis with it. And so I really want you to keep in mind these kinds of questions in this aspect of data management, because that's what we're going to be talking about today. And I wanted to start with this kind of silly question, but this is actually a really important thing to be mindful of, because in real life, science has a reproducibility problem. And for those of you that aren't super familiar with the research science world, I'll tell you a little bit more about that. It means sometimes experiments cannot be easily repeated, or when they are repeated, they result in different data or different results. And why is this happening? There's a lot of debate right now about what could be leading to the reproducibility crisis, but we know part of it is that oftentimes the methods describing an experiment are not being published in full when that results are being published, so it's really difficult to know exactly what happened with that data. Or sometimes the results and data are not shared openly, so this means that only select people have access to the results and data, and not everyone can understand what exactly happened with that data, for instance. And why is this happening? It's not that researchers, aren't smart people. It's just that oftentimes they don't know how to manage their data, and they don't know how to document their data well. And that's because no one teaches you, typically. No one taught me how to manage my data when I was in grad school. My analysis was written on a sticky note that I put on my computer. And, I knew what it meant, but nobody else did, and it's not repeatable at all. So this is a real problem. In 2017, there was an analysis done where this Belmont Forum group asked scientists what their top issues were in working with data. And these are the top 4. Scientists often don't know how to work with complex data. There's a lack of data standards in their field. It's difficult to find relevant data. And also data management and storage are big issues. And I say here researchers lack these skills, but many people that work with data lack these skills as well. And so these are the main inspiration for the Frictionless Data for Reproducible Research project, which is the project that I work with. And so I'm going to be telling you more about the group I work for, Open Knowledge Foundation, and this Frictionless Data project, and getting into the technical details behind that. And then I'm going to be showing you a case study with this group called BCO-DEMO, which is oceanography data managers. And then, yeah, so you can see how we're working with their pipelines. Okay, so to begin, the Open Knowledge Foundation is a nonprofit. It was incorporated 15 years ago. And our main goal is to open up all knowledge. We really fight for a fair, free, and open future where all non-personal information is available. And then we're trying to open this up and give it to people so they can use it. And also trying to build communities, tools, and teach skills to people so that they can use this knowledge to really push positive social change. We have a fully remote team. I'm the only person in Austin. Everyone else is around the world. And we have a large global network. We have groups in over 40 countries. And then we work on many different projects, from working with governments to try to open up their spending data, to working with local libraries to try and make them be hubs for public data, and then also this Frictionless Data project that I will tell you about more now. So the main idea in the Frictionless Data project is to remove friction in research data so we can get from raw data to insight faster. And these are pictures of my team. It's a very small team. And we're all open source and we're community focused. And by community focused, I mean that we really depend on our community members to help with the project by using our tools and asking questions and giving feedback and asking for improvements. So while I have 4 of us pictured here, there's a lot of people in our community that I want to thank as well for really helping us and constantly pushing forward work on this project. Here's the link to our GitHub repository, and there will be, again, a lot more links in here that you can look at later. To tell you a little bit more about this project, we are grant funded. We're funded by the Alfred P. Sloan Foundation, and then we're overseen by the Open Knowledge Foundation. We work with researchers in a variety of collaborations. The first is fellows, where we are working with early career researchers to teach them data management best practices and teach them about open science principles and how to use the frictionless tooling. We're working, for the Tool Fund, we're working with developers to help build new tools for reproducible research. And then the pilot projects are a really intensive one-on-one collaboration with specific researcher groups to try and resolve their data workflow issues. And I'll be focusing on the pilot project when I talk about our oceanography collaboration. So what is frictionless data? I've said that word a lot in the past few minutes. The idea behind frictionless data is removing frictions from working with data. But what does that mean? These are the steps, like the data cleaning steps, the steps I was talking about with the shrimp tacos. Things like, what's the license for this data? What does this specific data value even mean? Can I use data that was created in Excel and use it in Python without having any problems? Who created the data? And also checking for the quality of the data. These are all of the things that you need to know to understand how to use the data, and that can be very time-consuming. So this project, we are working to remove these frictions, and we have the backbone of the project are specifications for data and metadata interoperability, and then also a collection of open source software libraries that work with these specifications. And then we also have a range of best practices. And then importantly, all of this is platform agnostic because we're really trying to support interoperability. At the core of frictionless data is the data package, which is a simple container for data and metadata. And to help you wrap your head around what that looks like, I like to use this idea of a shipping container that contains data. So inside of our data package shipping container, we have our data, and typically we work with tabular data, so I have a CSV file as an example. And then along with the data, you have its associated metadata. And for those of you that have never heard the term metadata before, it's the data about data is the description of that. And it's things like what's the license, who created the data, what format is the data in. And then optionally, you can also include a schema inside the data package. And this tells you information about the format of your data. So it can tell you, like how many rows and columns you have, or it could tell you what your missing values mean. It can tell you very important information about the contents of that data. And together, all of this is the data package. And to help you think more about why packaging data is useful, I'm using Legos. I'm sure many of you have used Legos before, and one of the best things about Legos is that you can take Lego pieces from different sets of Lego, and they work immediately with each other. You don't have to do anything to, build something out of multiple sets. And this is the same idea with the data package and its interoperability, is that you can think of different tools as different Lego pieces that you can automatically work with the data package because it's so interoperable. And for instance, you can take the data package and immediately work with it in Pandas or R. And we also have our own open source tool called Good Tables that I'll tell you about more as well in a minute. Okay, this is a screenshot of some of the software that we have. This is a screenshot from our website. And I just want to show you this because we have a lot of software, and our main libraries are in Python, but we have most of the libraries translated into other languages as well, like JavaScript and R and Ruby, for example. And if you are interested in any of these other languages, I encourage you to check out our website and, again, the GitHub repository. Okay, so since we're at PyData, I'm going to focus on the Python libraries. And we have 4 main Python libraries that we use for frictionless data. The first is called Data Package Py, and this is useful for creating and using data packages. And so what this means is that if you have a CSV file or a data file, then you can put it in Data Package Py, and you can automatically infer metadata about that CSV file, and then you can package it together and export it and use it with different tools. The table schema library is useful for writing data schemas, and again, this describes the data. So again, you could have a CSV file, and then table schema will automatically infer the schema based off of that CSV file. And then we have good tables, which is for validating your data with or without a schema. And so the way this works is, say you have a CSV file and you then want to be able to validate and make sure that, say, like every data value in column A should be a string, then you can do that with good tables and with your schema. And then the final library I'm going to focus on more in a few slides, but this is data package pipelines, and this is kind of combining all of the previous steps into processing pipelines. So the real reason why we have these libraries is to help remove friction in the data. And so I have 2 use cases of how they are helpful for removing the friction. And the first is you have a user, he opens up a CSV file and says, what does this data even mean? Like, I don't know what this code in the data means. And the reason that that can be difficult is because you don't have good metadata associated with it, or like a data dictionary. But if you have your data packaged into a data package, then you have that metadata present, and also the metadata is machine readable. I think I forgot to say that we always have the metadata in JSON, so it's machine readable, which helps with the interoperability as well. And then my favorite use case, the second one, is when somebody is using Excel and they say, oh no, Excel converted a value in my data without telling me. And this actually happens in science fairly frequently. There are these horror stories about genes that sound like dates. So for instance, there's a gene DE7, which Excel automatically converts to December 7th. And it doesn't tell you it's doing it. It just does it silently. So if you have thousands of pieces of data and you have these genes present, you might not notice that Excel changed the content of your file. And so there have actually been research studies that were published that had to be revoked because the analysis was incorrect, because the researchers had analyzed their gene, they thought they were analyzing gene names and they weren't. So a way to avoid this is validating your data. And it really helps to have a schema to be able to do this. And so Good Tables allows us to validate the data based on a schema. And it will tell you, column A is supposed to be strings, but I detected a date format in this row, and it will give you an error, and it will tell you exactly what the error is and where the error was found so that you can go in and manually change that data value back. So this is very helpful. Okay, now I want to talk more about data package pipelines because this is what I'll be talking about when I get to the use case. Data package pipelines is a Python framework for declarative processing of tabular data. The pipelines are defined in a file called pipeline spec, and it's a YAML file, and so it's human readable. And inside this pipeline spec file, we have specified the processor steps that are taken during the pipeline. We also have the execution parameters. And so this allows the pipeline to be reproducible because we have a record that's human readable of everything that happened during that process. And then DPP also includes standard data processing steps out of the box. Things like joins, find and replace, add and remove a column, or unpivot. But in addition to these standard processor steps, you can write custom processor steps for your own use case. And this is in Python again. And then the output of the data package pipelines is a single data package. So you have your data, you have your metadata in JSON, and then you also have this pipeline spec file. And again, all of this makes it a very repeatable process and helps with reproducibility. And again, here's a link to the GitHub repository where you can see this code. Okay, so now I'm going to switch and start talking about our use case. So this is a collaboration with this group called BICO-DEMO. And that stands for Biological and Chemical Oceanography Data Management Office. It's a mouthful. But they are a group that is a repository for all oceanography data that is produced by researchers that are funded by the NSF, which is the National Science Foundation, which is a really big science funder. So they get a lot of data about the ocean. And so scientists submit their data in all sorts of formats to this group. And then BICO-DEMO has data managers that go in and they clean up the data. They remove the friction from their data, and then they host it and provide access for the public and for other scientists to then pull down that data and do analysis with the data. And BICO-DEMO is really trying to support reproducible research as well. Oh, I also want to mention that I took a lot of these slides about BICO-DEMO from Amber York, who is one of my colleagues at BICO-DEMO, and she gave a great talk at CSVConf last year, and the rest of her slides are at this Zenodo link if you want to check those out. Okay, so I want to show you what some of the BICO-DEMO data looks like because I find it's just so messy, and I find it very interesting. So for instance, they have data about coral reefs that they receive. They have data about the salinity of the ocean water. They have data about jellyfish. They have all sorts of interesting data. And it comes in various formats, too. If you can kind of see my mouse here, I'm showing you a date range, which is all in one column, and it's not in a standard date format. So as you can see, it's pretty messy data, and you can imagine that these data managers have a lot of work cut out for them. So one of the big goals of our collaboration with BecoDemo was to use data package pipelines to try and help the BecoDemo data managers with this big task of cleaning the data to try, again, remove the friction from this data process. So here are some examples of what types of things the BecoDemo data managers do to data. For instance, they frequently have to add spatiotemporal context in standard formats. Things like date and time zones, latitude and longitude, the depth at which the sample was taken from the ocean, and often you can imagine they get data from around the world. It's in different time zones. It's in different date formats, and so they want to be able to standardize that data so that anyone around the world can then use it. They also have to do things like correct quality issues. They get data that has inconsistent formatting. They have corrupt data characters or data gaps even. Sometimes there's wondering, is that missing value actually a missing value, or did the missing value connote some important information to the researcher? And then they have things like invalid species names and also just simply typos, which I'm sure many of you are familiar with if you've worked with data that other people have created. And so all of this, they have to reformat for reusability. So together, our team has been trying to help them streamline this process by working with data package pipelines and creating a UI for the managers to use. So overall, the main goal is to take this messy data that BecoDemo gets submitted to them and then turn it into nice, clean data that they can then host for other people to reuse, and to have this entire process be transparent and open and reproducible. So I love this slide and this concept of the scientists are out, they have a difficult job already working in the Arctic, and then we're also asking them, well, did you record the metadata? So this is where I like to think that the Frictionless Data Project is able to come in and try and help with this great work that these scientists are doing and make this data really usable. So how is data package pipelines helping? First of all, it gives data managers a more immersive experience with this new improved UI, and it reduces dataset processing time. It also removes the barrier of programmatic ability for the data managers, and it avoids having them have to handwrite pipeline spec YAML files or Python scripts, which eliminates errors and is much faster. Importantly, you can also add custom metadata to the pipeline. And I think I already said this, we have some additional custom processors that you can build into the pipeline. For instance, BecoDemo has several processor steps that they do over and over again to data files that are based on ocean-specific data. And so they were able to write specific processors for their ocean data and add that to the DPP pipelines. Okay, I want to show you an example of what the pipeline tool UI looks like so you can understand it. So first of all, the data manager would load in the data, and then they do different processor steps. Each of these arrows is a different processor. For instance, they can round a field, they can do a find and replace, they can do some computational changes to fields. You can do things like convert a date or rename a field, etc. And then here on the right, we're showing you an example of changing a time field. And you can see down here in the note, they've written fix inconsistent time format. Some didn't have seconds. And you see they add in a pattern and a replace pattern. And then the output of this pipeline is this pipeline spec YAML file that shows the next data manager exactly what happened during that pipeline run. So you can see it's in YAML, it's human readable. We can see, oh, they fixed the inconsistent time format and why they did it. And then again, this find and replace pattern that is very repeatable and understandable. So I want to give you another example of one type of change that happens frequently with this data, and it's changing the date format. And so here in this first example, this would be the data that they are given, and it has the date at April 16th, 2018, which is how us Americans would write the date, but it's how no one else in the world writes their date, and it's not standardized. And so if you were somewhere else and you were pulling down this data, it could be very difficult to know what this date exactly meant. And so this pipeline processor took that column and changed the date, made it standardized. So it actually ended up with 2 columns. The first is the ISO, so standardized date format, with a time zone. And then they also kept the local date time, but made it a more standard format. And this is a pretty simple example, but it's actually really important to be able to manipulate the data in this way to make it more usable. And again, the output of the data package pipeline is this change, which is documented in the pipeline spec YAML file. And then you also get the data spit out, and you also get the data package JSON file that has the metadata included. So together, all of these files are packaged, and they make this process very usable, repeatable. So our main goal here was to go from this messy data that BecoDemo gets and then run it through the pipeline in an easy-to-use way by these data managers, and so that you output the pipeline spec file, the metadata, and the data in nice, easy-to-use formats. Okay, so that's where we've gotten so far at this pilot. The next steps are to release the open source community version of the pipeline UI. And so the pipeline UI isn't quite done yet. That's why it hasn't been publicly released. But they'll also release their custom processors, and they have a statistics calculator that happens in the UI as well. And then this would allow the public to rerun pipelines or build up upon existing pipelines, which could be really cool. And then the next step is also to integrate good tables data validation into the pipeline. So this would allow for data validation to occur during the pipeline steps, and to hopefully avoid things like, oh, my string was turned into a date. And I just want to end by saying I can't say enough good things about the BecoDemo group and the interesting science that they're doing. So if you're interested in oceanography science in any way, I really encourage you to check them out. And I have listed their website and their Twitter account and their GitHub, where you can look at the software that they're building. Okay, how am I doing on time? I'm pretty good. Okay, I am now going to get into the stuff that I wasn't going to talk about a lot, that I just really want to leave up here for y'all, so that if you want to play around with the frictionless data code and tools on your own time, there's lots of links here. So if you are interested in learning more about the frictionless data tooling, I encourage you to first start by going to our field guide. And this is a good place to start. It has tutorials and some documentation. We also have web browser tools that I didn't talk about. So in addition to these Python libraries, we have these browser tools that anyone can use. You don't need to know any programming to use them. So for instance, the data package creator allows you to input data from local or a URL, and then you can package that. You can enter in your own metadata, or it will infer metadata for you. And you can download it and use it later. We also have a browser tool for good tables, and so this, again, will allow you to insert data either locally or from a URL, and then validate that data either with or without a schema. And we also have a continuous data validation form of good tables, which is integrated with GitHub. So every time you push your new data to GitHub, it will validate it. And here's an example of what that would look like. It will show you, specifically, oh, you had 26 errors, and these are the types of errors that you had, and this is where the error was. So you can go back and fix it. All right, and with that, I'm going to end so that I have time for questions. But I want to say thank you, and also really try and push you, if you're interested, to join our community. As I said, we are very community focused, and we're all open source. So again, the link to our GitHub repository And then the second link is to our Discuss forum, where people post, big picture questions and stuff, stuff that's not only about frictionless data, but stuff about like open licensing and open data in general. And then we have a Gitter chat room where you can ask technical questions, and our team will help you, and the community will also help you. And then we have some other YouTube videos you can look at, and again, the field guide. And yeah, I think that's it. Thank you. In the back first. Yes. I'm having a hard time hearing you.
Numerical data, units standardization. How do you handle those if you have a lot of numerical data?
Oh, I think we have a mic coming. This would help.
Okay.
Okay.
My question is, you handle a lot of data comes from, I saw one source, but probably many entities are entering it. Mm-hmm. When you have it, there's a lot of confusion, and you actually explained how and why. Specifically, if you have a lot of numerical data is associated usually with units of measure. How do you handle those? Mm-hmm. Do you have a standard already that you adhere to, or if not, do you want to do it? This is my first question.
Yeah.
Let's start with this.
Okay, yeah, we'll start there. So our specifications that we have written are very generic by design so that people can then take them and make them more specific. So we actually have a lot of discussion right now about this units question because there isn't, right now the units are not built into the specs, but we've been talking about it a lot. Okay, do you have, oh, okay. Okay.
I think this is awesome. I've been
Thanks.
struggling with data pipelines, and I keep writing for the last couple of months, writing code I work in oil and gas. So every time I go to a project, every project is completely different. So one question is, what do you do when you have to go back and correct one piece of the data? I think that you end up with a CSV file. But in my case, in my projects, I always have to push to a database, and I find myself that I have to correct some previous data in the database. So how do you handle those situations?
I would say I don't personally have a lot of experience with that aspect, but I think typically you would rerun the pipeline, and that's why it's really helpful to have everything written down in that pipeline spec file. But yeah, I think if you needed to make a change, you'd probably need to rerun it.
I'm just curious what kind of adoption you've seen of this tool so far.
Yeah, so this project's been around for I think 10 years. The Frictionless Data project as a whole has been around. The specifications were released just a few years ago and as like a V1 release. And the reproducible research specific aspect has only been going on for a year. So with scientists, we don't have as much adoption yet because we're really trying to build up adoption there. But we have a lot of adoption with like open government data and spending data, a lot of budget data. Oh, I think, did you have a question first?
Do you guys have any plans to allow integration of something like this into a sort of like a workflow scheduler like Airflow or other sort of larger pipeline ecosystem tools?
Yeah, we don't have plans yet, but I would love to see something like that happen. And the reason we don't have that specifically in our plans is because we have such a small team, and we're really focused on working with specific researchers to resolve their problems. So like if a researcher had that specific use case, then it would be super cool. We also have we will have another round of tool funds. So if you were interested in helping build that, we give out grants to build tooling like that.
Do you have any competitors? Are there other groups working on similar projects? I mean, the idea is great, and if the world could all agree to use your tool, that would be phenomenal. But there's probably many other projects similar to this. So in a way, you have not a you have like another level of meta problems, because if all other people come up with different package containers for data, then you still have a mess.
Sure. Have you ever seen that XKCD cartoon that's talking about data standards? And it's like, oh, we have 13 competing standards, and we will write one standard to rule them all. And then it's like the next day, we have 14 competing data standards. So yeah, this is an issue that we've thought about a lot, and part of our specifications are meant to be very general so that they are maximally usable and interoperable, because we really don't want to be competing as much as we can. But I would say one of our biggest, I don't want to say competitors, but another group that we've been thinking about how we can integrate with is schema.org. And I don't know if you've heard about Google has a data set search now, and they use schema.org to help as the metadata for that data set search. So we've been thinking about that.
Does this tool support versioning or anything related to that? So if one researcher wants to update their data, would that just update the metadata piece, or you actually need to update the whole thing with the pipeline and everything else?
Could you repeat the very beginning of your question, please?
Does this tool support versioning on the data
yes.
set?
Yes, it does support versioning. Yeah.
Hey, so for the scientific community, it's usual to not just adopt some kind of specification, but mostly build an organic way of organizing data. And since the data can be really complex, like genetic or brain image data, it is usually comes from the community per se to build these kind of specifications. So I guess not more in the technical aspects, but more in the organizational aspects. How is the foundation targets to encompass this kind of organizations, this kind of specifications, like the brain image data specification?
Yeah, that's a great question, and it's something that we're still working on, and it's part of just us building up our network and talking to people that are, using the BIDS specification and trying to learn more about their needs, and then trying to figure out how we can work together to answer those needs. So yeah, I don't have a specific answer yet because we're still working on it.
That's great.
Yeah.
Thank you.
I have a quick question.
Okay.
Can we do just a pip install on something, or for now we have to fork through your GitHub account?
Yeah, no, you can pip install everything. Yeah.
Good. Any more questions? Anyone? Let's give a hand then.
Thank you.
Thank you so much.